Hi, everyone. As usual, I'd like to begin by thanking you for joining us and the Chan Zuckerberg Initiative for funding all NF Core events. We're joined today by Maxime Borry from the Max Planck Institute for the Science of Human History in Germany, and he will be presenting the NF Core coproid pipeline. Now, coproid has been described to help identify the true maker of Illumina sequenced coprolites or paleofeces by checking the microbiome composition and the endogenous DNA. I'm curious to learn how that's done. So excited for your talk today, Maxime. If you have any questions for Maxime, you can either unmute yourself at the end of the talk or use the chat function, and I will relay the questions over to him. So thanks very much for agreeing to present for us today, Maxime. I'd like to hand over to you now. Over to you.
Okay, thank you very much, Renuka. Hi, so as Renuka mentioned, I'm Maxime. I'm a doctoral researcher at now the Max Planck Institute for Evolutionary Anthropology. We moved from institute this summer. We're now based in Leipzig in Germany. And yeah, let me tell you in the next 15 minutes about this coproid pipeline that I developed and published last year. So, yes. So what we're going to talk about today. So we're going to briefly talk about what is a coprolite, the challenge of identifying their source, or sometimes their sources, the solution that we brought with coproid, and also because coproid was published more than a year ago, I will briefly touch at the end about NF Core then and now. So what is a coprolite? So if you Google coprolite, this is probably the picture you're going to end up on. This coprolite is actually quite famous. It even has its own Wikipedia page. It's known as the Lloyds Bank coprolite because it was discovered when they were doing construction work at the Lloyds Bank, I believe in London. And it's from the 9th century, so a bit more than 1,000 years old. And this coprolite is now in display in a museum. And the fun fact about it is one day, actually, while they were visitors, it actually broke in 3 pieces. So it was someone's job actually to re-glue this old poop back into one single piece. So if you read in the archaeological literature, you will very often find the 2 words coprolite and paleofeces used interchangeably. They are actually not exactly the same thing, but for the purpose of this presentation, and most of the time they will be used interchangeably. So why do we study coprolites? So coprolites are very interesting because they're in the window into the past of the gut microbiome of ancient individuals. So it's a way of studying the gut microbiome as they are in modern studies, but for ancient archaeological samples. So for example, there was this paper that was published, I think a month ago, where they looked at coprolite from different time periods, including one from the Iron Age, so 2,500 years ago. And they found proofs of blue cheese and beer consumption in miners from Austria. And without coprolite, you wouldn't be able to prove that they were actually using consuming this blue cheese and this beer. So it's quite cool. You can also look at things such as diseases and a lot of other things. So when you work with ancient poop samples, there is an additional challenge of identifying an origin. If you work with a modern sample, this question is quite straightforward because you sample directly from the origin. Let's say you do a study of the gut microbiome of Elmo that you're gonna eventually successfully publish in Nature. You know who did the poop that you're gonna sequence. You know whose microbiome it is because you're directly getting the sample from the source. But when you work with archaeological sample, it's not so straightforward. Coprolites are often found in an archaeological context where you can't really easily attribute them a maker or you can't really say who made the coprolite, either because there are no nearby human remains. Coprolites are very often found in isolation, for example, at the bottom of a mine. You know that there was human activity, but you don't have any skeleton, so you don't know really who made it for sure. Sometimes you're more lucky. For example, there were coprolites that were found directly in the guts of mummies. So in this way, there is no question, but some other times it's not so obvious. The shape and the consistency is quite often degraded. So for example, below you can see the picture of coprolites that we used in the Coprolites article. If the Archeological didn't identify them first as poop, I wouldn't have even guessed that they were ancient poop. And very often in ancient sites, you have on the same place, people were living with their animals, especially pet animals that were domesticated or domesticated animals like dogs and pigs. So you had mixed human and animal occupation, meaning that the author of the poop is could be different possibilities. So what we came up with in the coprolite pipeline, coprolite identification pipeline, is the following. So after some pre-processing, we go into two different parts, two different ways of identifying the host or the maker of the coprolite or the paleophysis. The first way is by comparing to the reference genomes with the S. I'll come back to it in a second. And the second way is to do some metagenomic profiling with some machine learning to identify the host from the microbial composition. And then at the end, we put them together to give a nice report to the user. So when you do host DNA competitive mapping, you basically align the DNA sequence that you have against your genomes, your most likely genomes. So for example, here, I took a modern pig microbiome study, and I aligned the reads that they got to the human and the pig genome. And I looked at the logfold2 change of human versus pig, or rather pig versus human. And because it's a pig microbiome study, you're expecting to find much more pig DNA than human DNA in your sample. And for most of the samples, it's actually true. There is, however, one surprising sample, and I let you come up with an explanation by yourself. But normally you shouldn't find that. And it was a bit surprising when I found that even in a modern sample, because it meant that probably contamination was already happening in modern samples. So when working with ancient samples, it was even more likely to happen, even though we take a lot of precautions. They're out there, the samples at first. So relying only on host DNA wasn't the only option. And also here, they said that it's unlikely that a pig ate a human, but the opposite possibility is much more likely: humans eating pigs. And if for pigs, it's not so much of an issue in the archaeological context. When archaeological look at ancient feces, it has been much more often a problem to differentiate human from dog poop. And the problem is even double because in some civilization, it is known that people ate dogs. So you would expect to find a mixture of human and dog DNA. So the second step that we took to circumvent this issue is to look at the microbiome composition by using taxonomic profilers such as Kraken2, then computing some sample pairwise distance metrics and doing some dimensionality reduction, where you can get this nice plot when you can see your different samples in this dimensionally reduced space. In blue, you have your dogs. In red and orange, you have your humans, and in green, you have some soil samples. You can see that they separate quite well. And based on this composition, and by comparing them to reference sample, here in this example, let's say we have an imaginary unicorn gut microbiome profile, a dragon gut microbiome profile. You get this profile, and you're asking which profile does it look the most similar to? So with some machine learning, a tool that actually called source predict. I realize I messed up the slide here. Okay, so sorry. Well, sorry, you're not going to see the slide. I forgot. There it's messed up. But with machine learning, you can basically identify the source of your sample by comparing them to reference sample. And at the end, how did I mess it up so bad? At the end, you get a nice report that I can show you here. Okay. Sorry for that. Yes. Yes. So you get this report where you have interactive report. We have the summary table of the different findings. You get in. You have your microbiome embedding. So your samples in the dimensionally reduced space. Here are test samples. The sync samples are more or less within the human cluster. And then we get the summary plot where you have both the endogenous human versus dog DNA and the microbiome profile that are summarized in one single plot. And we see that for two of the samples, it's quite clear that they are Homo sapiens. And for some of their samples, either because there is a disagreement between the endogenous DNA competitive mapping and the microbiome profile, or for some other reason, it is less clear. So that's the summary report that you get at the end of the Coprolite pipeline, plus a lot of other things that I didn't mention that are specific to ancient DNA. So NF-core Coprolite was the last release of NF-core Coprolite was published in April 2020, so more than a year ago, and more than a year in the NF-core short history, is quite a long time actually. That's why I kind of put this picture here, because if you look at the code of Coprolite, it kind of looks like you're doing archaeology of Nextflow code when you look at Coprolite. It was basically using NF-core tool version 1.8. And in 1.8 there was no NF-core schema, and of course there was no NF-core DSL2 or no modules. So when I look back at it, it's quite exciting to see that NF-core develops so rapidly, but it's also challenging to keep up a pipeline up to date with the latest template and the latest evolution of NF-core, especially when you don't need to update it so much anymore because it's working. But you don't need to add extra new functionalities. So that's it from my end. The repository is NF-core Coprolite. We published it in 2020, so the article is here, and there is a Slack channel #Coprolite. So if you have any question, now is the time, and thank you very much again for inviting me to present Coprolite.
Thank you very much, Maxime. If you have any questions, you can unmute yourself, and so I've enabled that. You can unmute yourself and ask them directly. Alternatively, you can put them in the chat and I can read them out. So let's wait a couple of seconds. Okay, so I don't see any questions pop up and nobody has unmuted themselves. Thanks again, Maxime.
Welcome.
We will be sharing the slides that Maxime presented today. They'll be uploaded to our website after being put up on Figshare. And now I'd like to announce that we have 2 more sessions lined up for you before the winter break. So please keep an eye out for announcements on the bytesize channel and on Twitter for future talks that will be coming up in January. So see you next week and stay